In this video I will show you how much power a fridge consumes from my own tests. And then I will show you how many solar panels you need to power the fridge 24/7. We will first figure out the daily consumption, then the idle consumption of the inverter. This is what most people forget. In step 3 we size the battery and then calculate how many solar panels we need to charge the battery. Let's get started. First we have to figure out the power consumption of the fridge. My fridge is rated at 75 watts. It also has a small freezer section. In my previous video, I talked about the total consumption of this fridge over the span of a week. The total power consumption over 1 week is 4,288 watt-hours. If we divide this by 7 days, we become 600 watt-hours. Now you might wonder, 75 watts times 24 hours equals 1,800 watt-hours. And not 600 watt-hours. You are right, let me explain. The fridge compressor is not running 24 hours. As you can see from this graph, the fridge doesn't run all the time. Normally, it runs only for 30% of the time, or 8 hours daily. Let's see if this holds true. 8 hours times 75 watts equals 600 watt-hours. In my case, this is spot on. This can be different for your fridge, depending on temperature and how many times you open the fridge. As a reference, I open the fridge about 10 times a day in an environment of 68 degrees Fahrenheit or 20 degrees Celsius. If you are not sure, I recommend using an energy meter to measure the power consumption of your fridge over the span of a week. Do you know the power consumption of your fridge? Share it in the comments, so other people can learn from you. We already know that the fridge uses 600 watt-hours daily. But what most people often overlook is the idle power from the inverter. You see, an inverter loses a bit of power, even when it doesn't run any loads. If we use a 1000 watt inverter, it can use up to 20 watts of power continually. That means we get an additional power consumption of 20 watts times 24 hours equals 480 watt-hours. It depends on the brand and the size of the inverter. If we combine the fridge power consumption and the inverter idle consumption, we get a daily power consumption of 600 watt-hours plus 480 watt-hours equals 1080 watt-hours per day. Now we can calculate how big of a battery we need. If you like the video so far, consider clicking the like button. From the previous slide, we know that we have a daily consumption of 1080 watt-hours per day. But what happens when the sun doesn't shine? You need to add some days of autonomy. I usually recommend to get 3 days. This means that when the battery doesn't get charged, you can still run the fridge for 3 days. In this case, we are going to use lithium batteries, because they are cheaper in the long run. We should use lithium batteries from 10 to 90% state of charge to extend their lifespan. Which means we have to multiply the capacity by 1.2. If you were to use lead acid, you multiply by a factor of 2. The formula becomes 1080 watt-hours times 1.2 times 3 days equals 3,888 watt-hours. If you use a 12 volt battery, you need a 300 amp hour battery. If you use a 24 volt battery, you need a 150 amp hour battery. And for a 48 volt battery, you need a 75 amp hour battery. We know how big of a battery we need to run the fridge. And now for the moment you came here for, the amount of solar panels you need. I recommend using a 48 volt battery, because your wires and your charge controller will be cheaper. A link to my recommended battery will be in the description. We have to recharge our battery in 1 day. Depending on the location, you will have an average number of sun hours. If we use the website PV Watts, we can fill in our location. Then click on Go, followed by Go to System Info, and then without changing anything, click on Go to PV Watts Results. You will now see a table like the following. we can see that Houston, Texas has a minimum of 3.5 sun hours during winter. That's right, we have to size the system based on the worst case scenario, and that is the month December, with the least amount of sun hours. So we take the 3888 watt-hour battery and divide by 3.5 sun hours per day. This becomes 1110 watts of solar panels. This might seem a lot, but remember that it's based on the worst month of the year, and we have 3 days of autonomy. You can repeat all these calculations for your own fridge and location, and see what you come up with. Only 10% of my viewers are subscribed. Subscribe so you don't miss out on future videos like this one. Watch these videos next.